Okay, in this video lesson, we'll be looking at imaginary numbers and I raised to larger powers. So, if we look at something from a previous lesson, simplifying the square root of 75, which is called an irrational number, what you were taught was to take the 75 and break it into two factors, where one of the factors is a perfect square. So 25 times 3 gives us 75. If I separate my two factors and give them each their own radical, then I simplify. Square root of 25 simplifies to 5. Radical 3, or the square root of 3, stays the square root of 3. Final answer is simply 5 radical 3. If I take it to the next level and look at the square root of negative 75, which is considered an imaginary value. An imaginary value is a number that exists, but you cannot locate it on the number line. So we're not saying we can't find negative 75. We can't find the square root of negative 75 on a real number line. But we can still simplify it. So I'll do the same thing, break it up into factors, where at least one of them is a perfect square. So we have the same 25 to 3, but now because of the negative, I can put one more factor, negative 1. So I'll work through the same procedure, give each factor its own square root, and then simplify. Well, the square root of 25 is 5. Square root of 3 can't be simplified. But the square root of negative 1 is the universal value I. I is similar to the value pi in the sense that we use the symbol pi to represent a very specific numerical value. So I is not a variable like x. It doesn't change. I is the variable, I shouldn't say that, the letter or the symbol we use to represent the numerical value, the square root of negative 1. So if I simplify this and just rearrange it, I end up with 5i times the square root of 3. I treat the I similar to the same way I would treat a variable. I place it in front, so it kind of like 5x, 5i. The reason why I don't keep it behind the 3 is because, for clarity's sake, so that there's no doubt that the I is not part of the 3 under the radical. By placing it in front, there's no doubt that only the 3 is part of the radical number. So I continue. Square root negative 36. Same scenario. Break it into two factors where one of them is a perfect square. Give each factor its own square root, its own radical, and then simplify. Square root of 36 is 6. And now the square root of negative 1 is our I. Simplifies to just 6i. One more example. Square root of negative 23. Again, I can break it into two numbers. And each time I'm just trying to show that this negative will become its own value, becoming eventually I. So separate it into each own, have its own radical. Square root of 23 stays the square root of 23, and the square root of negative 1 is I. Rearrange it for confusion's sake by simply putting the I in front. So that's just a reminder lesson on where imaginary numbers actually come from. So now, when we consider taking just the value of I and raising it to larger powers. So if I start with just recalling that I is simply the square root of negative 1. So if I take I to the 0, well, any number except 0 raised to the 0 equals 1. I to the first power is simply I, but I is the square root of negative 1. If we were to square I, well, what will happen is I'm showing that the square root of negative 1, which is I, squared. That square root and square essentially cancel each other out, leaving me with just negative 1. I to the third power, well, that's the same thing as I squared times I. I squared we saw was negative 1, and I was the square root of negative 1. Negative 1 times the square root of negative 1 is simply negative square root negative 1. Now that's a mouthful. You got all these negatives here. I to the fourth. is I squared times I squared. Well, I squared was already -1. -1 times -1 is 1. Then we realize, wait a minute, this is the exact same answer as I to the 0. So we wonder if this sequence is repeating. Well, let's take I to the 5th. I to the 5th, same thing as I to the 4th times one more I. Well, we saw I to the 4th was 1, and I was the square root of -1. Simplifies to the square root of -1. So I'm convinced that this sequence does start to repeat. So essentially, there's only 4 values in this cycle that repeats. 1, the square root of -1, -1, and negative square root -1. So what I'm going to do is create a little grid and see how we can develop a pattern to find out larger powers. So in each one of these, this will represent the exponent. I to the 0 equals 1. I to the first, square root -1. I to the second, I squared, -1. I to the third. And we saw I to the fourth starts the sequence again. I to the fifth, square root -1. So we can continue with the assumption I to the sixth, -1. I to the seventh, negative square root -1. To the eighth, ninth, 10th, I to the 11th. Sequence starts again. I to the 12th is 1. I to the 13th, 14th, 15th. I to the 16th puts us back at 1. 17th, 18th, and I to the 19th. So we're going to take this graph or grid of numbers and begin to establish a procedure, a protocol for determining the value of any I raised to any larger power. So we'll start with the grid that we created on the previous slide. And because there was a sequence of 4, I'm going to take an example, I to the 11th, and if I divide it by 4, so we already know the answer, I to the 11th, is going to be this, but we're going to test our pattern to see if this procedure works. So I'll take 11 divided by 4, again because it's a 4-number sequence. I end up with 2.75. Well, 2.75 is the same thing as 3 over 4. This 3 is the same as that 3. That puts us at this answer of negative square root -1. So we're beginning to establish some sort of pattern. Let's try a different one. I to the 19th. So there's our 19th. If everything works, we should have the exact same remainder here. So 19 divided by 4 is in fact 4.75, which is the same as 4 3/4. So this 3 is the same as the previous 3, making our answer the same negative square root -1. What I wanted to do before I do another example is just to show what 4 3/4 is actually saying. So if I start with the I to 19, that's the same thing as I to the 4th times I to the 4th times I to the 4th times I to the 4th. So 4 complete revolutions. That's what this 4 is saying. And I got 3 I's left over. 3 of the 4 left over. So this is what the answer is actually telling us with respect to the number of I's. So another example. So it shows 1 times 1 times 1 times 1 times I to the 3rd. There's our next example now. I to the 13th. Well, there's our 13. So if we divide 13 divided by 4, that gives us 3.25. The 0.25 is the same thing as 1/4. This one is the same as that one. So therefore the answer is the square root of -1, which we already knew. Another example, I to the 18th. There's the 18 that we're referring to. 18 divided by 4, 4.5, which is the same thing as 4 1/2, which is the same as 4 2/4. So this 2 is the same as that 2. creating the answer of -1, which falls with our graph here. One more example. I to the 8th, there's our 8. So 8 divided by 4 is 2.0. So this 0 is the same as that one, creating our answer of 1. So in essence, every time you divide it by 4, you were left with these purple numbers, specifically the purple decimals. So the decimals were either 0.0, 0.25, 0.5, and 0.75. So this is what we're going to be focusing in on. After we divide by 4, we're focusing on the remainders. So we'll do a few examples. We're going to first just record what we have so far. We know I to the 0 is 1. I to the first is the square root of -1. I squared was -1. And I to the third was negative square root -1. Our different decimals were 0.0, 0.25, 0.5, and 0.75. One mnemonic device could be this. You're talking about quarters, 25 cents. No quarters, 0. 1 quarter, 25 cents. 2 quarters, 50 cents. 3 quarters, 75 cents. This is a mnemonic device. So we'll do a few examples. I to the 63. So we take the 63 divided by 4. So if we go to the calculator, 63 divided by 4 gives us 15.75. So we have our decimal of 0.75. Right there is the same as that one. So our answer, negative square root -1. So I to the 63 is negative square root -1. Next one, I to the 109. So 109 divided by 4 in our calculator, 109 divided by 4 gives us 27.25. So 27.25, this 0.25 is the same as that one, which means our answer, square root -1. I to the 86. 86 divided by 4, let's see. 86 divided by 4, that gives us 21.5. So there's our decimal, 21.5. This 0.5 is the same as that one. So our answer is -1. Another example, I to the 304. So the numbers won't make a difference. You're still just going to do the same thing. 304 divided by 4. Calculator says that's 304 divided by 4. Calculator says 76, which is the same as 76.0. So the 0.0, same as that one. So there's our answer of 1. All right, so hopefully these examples will help you understand better.